Classifications of resonant converters. The resonant converters are defined as the combination of converter topologies and switching strategies that results in zero voltage or zero current switching. The resonant converters are classified as first, load resonant converters, second, resonant switch converters, third, resonant DC link converters, and fourth, high frequency link integral half cycle converters. We'll be concentrating on these four converters in brief. Load resonant converters. This converter consists of LC resonant tank circuit, oscillating voltages and current due to LC resonance. That means the resonance condition occurs when the reactance of inductance and reactance of capacitance become equal in a tank and are applied to load, and the converter switches can be switched at zero voltage or zero current. That means when the resonance condition occurs, the voltages and current goes to zero many times in a one cycle, since due to resonance condition the frequency increases, and if the frequency increases the voltages and current goes to zero many times in one cycle, and when the voltage and current crosses the zero, at that time the switching signals are given to the converter. Either a series LC or a parallel LC can be used in a load resonant converters. In this converter circuits, the power flow to the load is controlled by the resonant tank impedance, that means by controlling the impedance of L and C, which in turn is controlled by switching frequency Fs in comparison to the resonant frequency F0 of the tank. This DC to DC or DC to AC converter can be sub-classified as voltage source series resonant converter, and it is classified as series loaded resonant converters SLR, parallel loaded resonant converters PLR, and hybrid resonant converters, current source parallel resonant converters, and class E and subclass E resonant converters. So these are the sub classifications of series or loaded resonant converters. Second type is resonant switch converters. In a certain switch mode converter topologies, an LC resonance can be utilized primary to shape the switch voltage and current to provide zero voltage or zero current switching. In such resonant switch converters, during one switching frequency time period, there are resonant as well as non-resonant operating intervals. Therefore, these converters have also been termed as quasi-resonant converters. They can be subclassified as resonant switch DC-DC converters. Under that, zero current switching converter, that is ZCS, and zero voltage switching converter, that is ZVS. Zero voltage switching clamped voltage, that is ZVS CV converters, which are also referred to as pseudo resonant converters and resonant transition converters respectively. Third, resonant DC link converters. In the conventional switch mode pulse width modulation DC to AC inverters, the input voltage Vd to the inverter is a fixed magnitude DC, and the sinusoidal output might be single phase or three phase. It is obtained by switch mode pulse width modulation switching. However, in the resonant DC link converters, the input voltage is made to oscillate around Vd by means of LC resonance. That means by controlling the reactance of inductance and capacitance, we can oscillate the voltage around plus minus Vd so that the input voltage remains zero for a finite duration, during which the status of inverter switches can be changed, thus resulting in zero voltage switching. High frequency linked integral half cycle converters. If the input to the single phase or three phase inverter is high, frequency sinusoidal AC, then by using bidirectional switches, it is possible to synthesize a low frequency AC of adjustable magnitude frequency or an adjustable magnitude DC, where the switches are turned on and turned off at zero crossing of input voltages.